Good morning. So this is 415 Development and Growth 1. Today, after the midterm exam, we are going to continue with with some modern theories of economic development. This is again straight from your textbook, Todaro and Smith. Let me just share my screen. So we're going to look at the two sections today, section 4.1 and section 4.2. These are about coordination failures and multiple equilibria. So we want to get some sense of these. We want to get a good sense of these notions, because we're going to use these notions in discussing and in conceptualizing some contemporary models of economic development. Okay. So again, this is the outline. First, we're going to discuss coordination failures. Then we talk about multiple equilibria. One important concept here is complementarity. Okay, so if a decision maker's decisions affect the incentives of others in the economy or in the society, then we talk about complementarities. Those complementarities could be static or could be dynamic, right? So if I take a decision today and this decision affects your incentives for a certain decision today, if events happen in the same time, then we talk about static incentives, static complementarities. Or I can take a decision today and it would affect my or your incentives in the future, then it's a dynamic complementarity. So complementarities often involve investments whose return depends on other investments being made by other agents. Okay, so in a moment we're going to start talking about the examples of this, but you may think of your own examples. So there is also this short definition of coordination failure. Let me just read it. A state of affairs in which the inability of agents to coordinate their behavior or choices leads to an outcome or equilibrium that leaves all agents worse off than in an alternative situation that is also an equilibrium. So here we have a situation where there's just more than one equilibria. Okay, there's more than one equilibrium. So let's say there are two equilibria. In one of these equilibria, these people, these decision makers basically converge to an outcome that is better in some sense. Okay, so that if they can coordinate to this better equilibria, then they can achieve coordination. They all benefit from this. Why? Because there are complementarities. Okay, but coordination failure means they cannot achieve this outcome that make everyone better off. Okay, that makes everyone better off. So in development economics, we will see a lot of different examples, a lot of different mechanisms that would imply coordination failures, or we're going to see examples where poverty in a country seem to be originating from coordination failures. Okay. Interestingly, coordination failures are not about information. Okay. So even if everybody has full information, we can still observe coordination failures. Why? Because people's expectations can differ. Okay, some people could be optimists, some people could be pessimists, some people could have more knowledge, some people could have less knowledge, things like that. So if expectations differ, and here I'm talking about expectations, not price expectations. Here we are talking about expectations with respect to what others will do, right? So today, for instance, at 9 a.m., my decision is to start the Zoom meeting and present the lecture, or not do that. Okay, and obviously on the other side of my screen, there are yourselves. So you took also a decision whether come to class, open the laptop, log into the Zoom, come to class, or not doing that. All right. And obviously, how many of the people are here? Let me just see it. Obviously, okay. We are now exactly 20 people here. So 20 of us coordinated their behavior. Okay. And now we are benefiting from this. You may think of this in this way, right? Okay, this concept in this way. So, but if I had very diverse expectations about your behavior, or if some of you assume that Dr. Attar will not show up today. Why? I don't know why. But if he or she had this expectation, then he or she could not coordinate himself or herself for attending the class, right? So that type of thing. So expectations matter. And also, in some situations, especially in the field of investments or entrepreneurship, we will see that everybody would be waiting for somebody to take the first move, somebody to take the first step. Okay, why? Because again, there are complementarities, and the first movers will usually pay higher costs. Okay, because at least they pay the cost of learning the environment. All right, imagine that there is this industry. Okay, so there is basically a particular good or service that you can produce, but it is kind of new, and everybody is not, nobody's familiar with the production technology. Let's say there's this old production technology and the new production technology, and you are kind of thinking switching to the new technology because supposedly it is better and more productive. But then you also don't know a lot of things about the, about the profitability of this technology and other stuff. Whether you can, successfully adopt these practices, etc., right? So there is some uncertainty there. So if you want to be, if you kind of risk averse and protect yourself from such risks, then you would wait, because some other firm will possibly switch to this new technology, and through the experience of this other firm, the first mover, I can learn the costs better, right? So in such a situation, every firm will have the incentive to wait, right? Because some other firm will be the first mover and pay the initial, let's say, knowledge costs or uncertainty, revolution costs, and then I would benefit from this. But then this is a simple tragedy of commons type of argument. So if everybody waits, if everybody has the incentive to wait, because the first mover will have some disadvantage, then everybody waits and nobody becomes the first mover, then the economy cannot adopt the new technology, right? So we will have situations like this, right? When we talk about coordination failures, important thing is that it can happen with full information, okay? Because full information does not mean full rational expectations, okay? All right, so here there is a hypothetical example. So in this example, we have some college friends. A couple years after the graduation, they try to meet in Ankara on the New Year's Eve. Okay. So every one of them will be in Ankara in that day, and everyone wants to meet. Okay, so these are close friends. For some years, they didn't meet in person, so it's a good occasion. The New Year's party is a good occasion to meet, and everybody knows everybody will be in Ankara. Okay, but they cannot communicate about where to meet. Okay, for some reason, since this is a hypothetical example, for some reason, they cannot talk to each other. Okay, so in that case, what would happen? Well, most possibly, some groups will go to some place in the city, a place they used to go a lot in their college years. Okay, some other group will coordinate their behavior in some other place. Okay, so one group goes to Tunalı, another group goes to Armada, another group goes to Eymir. Okay, without communication, you have to you have to build on some other heuristics, some other type of information. All right, then expectations matter, right? Because you cannot communicate with your friend, so you only form an expectation of what he would do or she would do. All right, and then there's a failure because not everybody can meet in the same place. Some groups again go to some place, some groups go to some place, and they only meet their friends there. Okay. So now there's a economic example. Okay. This is very typical. It's in the game format, as you see. It's actually a game, by the way, but the example is this. So there are firms in the economy, okay, and there are workers. So obviously, workers are employed by the firms to produce goods and services, right? Now, firms have, in this very simple example, the firms have two options. Either they invest in new technology, right? Or they do not invest in new technology. So it's like a 0-1 decision. After the 0-1 decision, of course, if they decide to make an investment, then they would find the optimal level of investment, etc. Right? But here we are going to look at whether they invest or not. Okay, and each firm takes a decision, right? And on the workers' side, they also face this binary situation, right? So they face a decision, a trade-off for investing in new skills. All right. So if, as workers, they spend some time learning, this could be on-the-job training or some, some teaching programs that they could attend. But basically, they can invest in new skills, or they just wouldn't, right? So this is just the binary decision problem that workers face. Each worker thinks about himself or herself and takes a decision on investing in new skills or not investing in new skills, right? Now, where's the complementarity? You should ask, right? So complementarity is between new skills and new technology, right? Because if firms have new technology and if people have new skills, then there's a good match technologically. The skill set of the agents, of the workers, will match the skill requirements of new technology. So production will be highly productive. The production, in the production side of the economy, there will be high productivity. So high productivity will give the firm higher profits, and then in the meantime, it also gives people higher wages. Okay, so if you look at the table, investing in new skills by workers and investing in new technology by firms, this creates the best outcome, right? Firms payoff is 100, workers payoff is 100. Okay. Now let's look at the direct opposite of this. Direct opposite is workers do not invest in new skills and firms do not invest in new technology. Okay, so there's no R&D expenditure in the economy. There's no learning by the people. Everybody will have some set of skills by birth, let's say, and then they go to school to, at some years, let's say 10 years, then it stops there. Okay, no new skill investment for people, and then firms will be using the same old technology all over again. All right. Now, in such a situation, we normalize the payoffs to zero. Okay, so firms do not invest in new technology, they got zero. People do not invest in new skills, they got zero. Okay. Then there are the cross cases, the ones you see in red color here. Okay. Now these are, if you are into game theory, these are defection equilibria. Okay. So here on the top right, you see firms investing in new technology. Okay, so here firms invest in new technology, but workers do not invest in new skills. Then there is the mismatch, right? And in such a situation, again, firms investing, but people not, workers not investing, firms payoff is minus 100 and workers payoff is just zero. Why? Because firm pays the cost of adopting new technology, so firms make this investment, but since they cannot find high-skilled workers, they cannot benefit from this investment, okay? Because there is this complementarity between new technology and new skills. So new technology requires these new skills in the workers. So here, there is no coordination between the firm and the worker. So firm will invest, pays the cost, right? But workers do not take any decision in terms of invest. So workers do not invest. Then because of this mismatch, firms will not benefit from new technology. Then firms' profit will be lower than the case of no investment or investment. Okay. The same mismatch occurs in the other case, in the other cross case. Why? Because now if the workers will invest in new skills, they will pay the cost. But then if firms do not invest in new technology, those workers will not benefit from their new skills. Right? Again, because of the mismatch. Then in this case here on the lower left panel, you see that workers pay the cost for investing in new skills, but since they cannot benefit from it, their payoff is minus 100 and firms' payoff is zero. Okay. Now in such situations, of course, the good equilibria is the green one, right? So people investing in new skills and firms investing in new technology. But since this is this is basically a non-cooperative game, right? There are many Nash equilibria, and achieving this equilibria requires many stuff. So we're gonna see other examples. There's also this interesting farmers example. Let me also discuss this and then we take the break. So the idea is this. Since Adam Smith, we know a lot about specialization and division of labor, right? Now, specialization in farming or in agriculture more generally is good for the farmer, and it's good for the society as well, right? Because if the farmers specialize, they learn a lot about that product they target particular technologies that is suitable for the production of that product, there could be other benefits. Okay, other benefits for specialization. But specialization requires strong ties with the buyers. Okay, because if I produce only wheat, then I must be connected to wheat buyers. All right. So imagine physical connections here. I mean, not just economy. So where is the value chain? So what is the transportation cost? How can I find the correct markets for my product in this huge world, right? So not just think about the city or the region. Imagine this global market for wheat, and I want to produce wheat, but then I must be in contact with wheat buyers. Where are these buyers? And I need to know them, right? So in such situations, middlemen play an important role because they can facilitate such a matching between producers and buyers, right? So if I want to produce corn, again, I want to learn where are these corn buyers. Okay. Now, if they are connected, then they can specialize. If they remain not connected through the middleman or through their other ties, other technologies of matching, they will not specialize. Why? Because if they cannot sell wheat, maybe they can sell the rice. So they produce then a large set of products, including corn, let's say maize, rye, and wheat, and they can sell however they can sell. Okay, what's the problem with that? Well, they cannot specialize. That's the problem, right? So they remain in this small scale producing all goods equilibrium. But connected farmers, where they pay some, of course, some premium for working with the middleman, maybe they can still benefit from specializing. Right here, connectedness matter. Okay, so I can also talk about deep intervention. Obviously, you would ask, what does the government do, right? Okay, so if in the economy or in the society, if we have such coordination failures, we have these complementarities. Because of these complementarities and different expectations, people usually face these coordination failures. What does a government do? What can a government do, right? Here, one thing is called deep intervention. Okay, so basically, you want to create a policy shift that creates better incentives to move the economy to the better outcome. All right, to coordinate the actions of people and firms and whatever these agents, so that the better equilibrium is self-sustaining and people's decisions are coordinated towards that equilibrium. So if I read it, a policy that can move the economy to a preferred equilibrium or even to a higher permanent rate of growth that can then be self-sustaining, so that the policy need no longer be enforced because the better equilibrium will then prevail without further intervention. So some of you also take my general equilibrium class, right? So this sounds a lot like the second welfare theorem, right? So there is this better equilibrium. Even if they are both parity efficient, one equilibrium is certainly better than the other. Imagine that that better equilibrium is, in our earlier example, firms investing in new technology and people's or workers investing in new skills. then to coordinate the actions of people towards that equilibrium, for instance, I, in the meantime, give firms some R&D benefits, some tax benefits if they are doing R&D, if they invest in new technology. And in the meantime, I basically make college education free. Okay? And I give scholarships to college students. I can actually target this in a sector-wise way, right? So I could imagine that, all right, in the 21st century, artificial intelligence will be a huge technological issue. It will be increasing firm productivities and worker productivities in many different sectors. So it's like a general purpose technology. So then I can give R&D subsidies to firms that will invest in artificial intelligence. And in the meantime, I will give generous scholarships to people attending artificial intelligence departments or researchers specializing in artificial intelligence research. Okay, so you can basically target sectors. It doesn't have to be artificial intelligence. You can target your automotive industry, right? You can target your I don't know, ceramics, okay, tourism. So it just depends on your conditions. What are your country's endowments? Okay, how complex these technologies are, etc. But in general, deep intervention requires affecting the incentives of many other types of agents in the economy, not just firms, or not just a small group of firms. Okay, so I'm gonna continue exactly from here. We have about 1.5 minutes. So do you have any questions? Okay, so my time is 9:40 almost. I need about 15 minutes for conversion, video conversion. So let's meet at 9:55. Okay. At 9:55, we're gonna continue with the notion of deep intervention. Okay. All right. I will see you at 9:55.